we go, folks. This is section 5.2, standard form of quadratic functions. I realize I made the mistake of calling the previous section 4.1, but we are indeed in the 5th chapter. So the standard form of quadratic functions, this is just a different way to look at it, okay? A different type of formula. We looked at this one yesterday, where y equals ax squared plus bx plus c. Remember, a can't be 0. If a is 0, this goes away. We end up with what we call a linear function, right? But we have a quadratic function. It's a different shape, so we have to keep that a value not 0. It's got to be like a 1 or anything. Actually, it could be any number. Now, one thing we could get from this, remember that the y-intercept in this case is c, right? Because if x is 0, boom, that's 0, and we have it equal to c. If we want to find the x-intercepts, right? If we want to find the x-intercepts, we make y equals 0, and we end up with a formula or an equation that looks like this: ax squared plus bx plus c equals 0. And we end up factoring this to find out the zeros, right? So that's what we've done up to this point. Today what we're looking at is something called the standard form of the equation, okay? Standard form of the quadratic function, I should say. And this shows us, well, it's also called the vertex form, because it actually gives us the vertex, and we use this for graphing, okay? So this is for graphing, okay? And we have a few tricks, just like we did with absolute values and with the other functions. We have a few ways to move these things around. Now, if I gave you a function that looked like this, x squared plus 2, I'm hoping that you see that if this is your original function, 1, 1, 2, and 4, right? 1, 1, 2, and 4. This is your original function, right? Plus 2, so this is just y equals x squared, sorry. Plus 2 means the whole thing goes up 2. So your vertex now goes up 2. This point goes up 2. This point goes up 2. All points go up 2. You can also generate your parabola from this point. If this is your vertex, over 1, up 1, over 2, up 4, and you end up with a parabola that has gone up 2. Okay. Similarly, if I went down 3 or something, then the whole thing would just go down 3. Okay. Here's a quick summary for the vertical slides. K is what we call a vertical translation or a vertical slide. And if K is greater than 0, then it goes up K units. And if it's less than 0, then it goes down K units. All right. Now let's look at a different situation. How about if I had y is equal to x plus 2, but all squared now? If you remember the applications, or when we dealt with the absolute value functions, we looked in here. For example, remember we had x minus 2 like this. You guys figured out that that moves to the right 2. We ask ourselves, what do we have to do to get back to x? Well, you add 2, so it goes right 2. This one got a plus 2. What do you have to do to get back to x? You subtract 2, so it goes left 2. And that is my new vertex, okay? So over 1, up 1, back 1, up 1, over 2, up 4, back 2, up 4, and we have a horizontal slide, okay? Very similar to what we've been doing in the past and the other ones. Like I said, every function works the same, right? So now if we look at the horizontal slides here, right? If you have something like x minus 3 all squared, that means that it goes to the right 3 units. Okay? If I have x plus 2 all squared, that means that it goes left 2 units. And now we're at the stage where we can actually graph lines that would look something like this. If I gave you a function y equals x plus 1 all squared minus 3, right? Well then, you know that it goes hopefully down 3, and this tells me it goes left 1. So you can look at your vertex right now, and it's minus 1 and 3. Look at these numbers, and look at these numbers. Okay, because right now, I'm going to tell you that the vertex here, the vertex is always h and k. Okay, the vertex is your h and k value. So now that you have the new vertex, you just graph this function from here. So we're going to go over 1, up 1, over 2, up 4, back 1, up 1, back 2, up 4, and we have our parabola. Boom. You could guess at the x-intercepts about 0.8 and negative 2.8. You could find your y-intercept. It looks like it's negative 2. You can find your axis of symmetry. It looks like it's x equals negative 1. All those pieces of information we can get from that graph. Okay? The only way that we could change this now is if we put a negative in front. That just means that instead of going over 1, up 1, over 1, down 1, back 1, down 1, over 2, down 4, back 2, down 4, and we end up having the same parabola, but opening down. So that, ladies and gentlemen, is your horizontal and vertical slides. The next thing we have to look at is this a value, okay? Now the a value changes the shape. So if we look at x squared is over 1, up 1, over 2, up 4, right? Back 1, up 1, back 2, up 4. There's my graph. Now if we look at y is equal to 2x squared, what this basically means is that you're doubling all your values, right? So if I went over 1 and up 1, now instead of up 1, I go up 2. Back 1, up 1, well, up 2 now. Over 2, up 4 is now over 2, up 8. So what you end up getting is a steeper graph, okay? Actually, it's twice as steep. All your y values get doubled. And if you think about a different situation here with 1/2 x squared, right? Let's make the numbers a little bit bigger here so we can see negative 2, negative 1, 1, and 2. That's 1 and 2. So now if I went over 1, I used to go up 1, but now I just go up 1/2 because I've got 1/2 here, and the same on the other side. It used to be 2 and 4, but now it's 2, and 1/2 of 4 is 2 again. So what you end up with is a fatter graph, okay? So this a value in front here, this a right here, is what we call a vertical stretch, okay? It's a vertical stretch. And let's look at a bit of a summary here, okay? If your a value is greater than 1, right? This one is y equals x squared, and this is 2x, wait, sorry, the other way around. This one is x squared, this is 2x squared. So that means that it's a vertical stretch, okay? And if it's less than 1, it's a vertical shrink if you want. And the other thing that the a can do is that it can be negative, and that means that it opens down, okay? So you've got a bunch of different situations here. And what I'm going to do is see if we can graph some of these. So let's look at y is equal to, let's go 3x plus 2 all squared minus 4. Okay? So the first thing that we can do is get the vertex. And we know that it's moved left 2 and it's gone down 4. Okay? So let's start with that point. We'll go left 2 and down 4, okay? So once you've got those, you're basically finished with them. And what we're looking at graphing now is just 3x squared, but we go from this point. So now, 1, 1, 2, 4, right? So 1, 1 becomes 1, 3, because we multiply it by 3. 2, 4, or 2, 4, sorry, becomes 2, 12. So 4, 5, 6, 7, 8, 9, 10, 11, 12. And we go same on the other side. Now you can see the numbers are getting big quickly, so we can only graph a couple points, and you end up with a steep graph like that. Okay, let's try another one. Oh, and from this you can get your axis of symmetry, right? Your domain and your range, hopefully. Well, let's look at all those questions. Okay, so there's your vertex. Your axis of symmetry, right, would be x is equal to negative 2. Your y-intercept, we can read it off the graph, is 8. Your x-intercepts, we can read it off the graph. We're going to have to guess. It's like negative 0.8 and negative 3.2, say. If we look for our domain, it's going to be x is all real numbers, because it always is all real numbers. If you look at your y, it's greater than or equal to this lowest value of negative 4. What are we looking for? And it's also a min. It's just a minimum. Those are the questions that you're going to need to answer for all these graphs, okay? I can help you graph one more if you like. Let's look at y is equal to 1/4 x minus 4 all squared. Well, hopefully what you'll notice right away is that you don't have a vertical shift. So that means that you don't go up or down at all, but we do go sideways, and we're going to go right forward. Boom, there we go. And now let's graph the rest of it, right? It used to be over 1 and up 1, and a quarter of 1 is a quarter, so we'll just go up a little bit. Got to take a bit of a guess. Over 2 up 4 is now over 2 up 1. Over 3 squared is 9, and a quarter of 9 is 9 quarters, or 2 1/4. I used to go over 4 and I'd go up 16, and a quarter of 16 is 4. So you can see that we've got a significantly fatter graph, and I've got a bunch of solutions already. There's my y-intercept, right? There's my x-intercept, there's my axis of symmetry, and we can answer all those questions. Hopefully that made a little bit of sense, folks. Any feedback would be great. Have a great day.